All right, welcome back, everyone. Hope you can see and hear me all right. I know I haven't streamed for a while. Just some space. All right. Still getting some followers, so thank you for following me on Twitch. Even though I didn't stream for like 2 months, or maybe I think the last one was November, early November, so maybe for 4 months. Today I want to work on my constraint solver package for like, I don't know, an hour and a half or 2 maybe. And because I haven't worked on that one for a while, for like 3 months, and started last week again. And I've opened some issues up. So I don't know why my chat is going weird. Normally I was able to write in that. Let's write it to the Twitch chat. So that's my project. Let me check out whether I can see chat from YouTube. All right, that looks good. Okay. So I still have a pull request, which is like super old. I don't want to work on that one today. I've opened 3 issues for so-called element constraints. So this one is the most basic one, where you have an array of constant integers, and you want to index it with a variable. The second one is the same thing in 2D, and the third one is where this one isn't constant; it's a vector of variables itself, which will be more complicated. So maybe I will do this one in the second part of the stream, depending on how far we can go. Yeah, so because someone wanted to use the constraint solver for some basic stuff, and he has a nice website of different problems. Oh, Il is back. Basically, I am back, and thanks for joining. You're probably here the whole time, but I wasn't here. Okay, so what I want to work on today in the first part is to have this get next nodes function using a priority queue. I think I don't want to. Yeah, I think hopefully you can still read this. So is that the function? Oh no, actually, what is this one? So they're actually, so getting the next node basically means we are building the search tree, and we have currently 3 methods, which are depth first search, best first search, and depth first search, and when a solution found, then best first search. And the basic one or the automatic default one for feasibility problems in this DFS, but they are all implemented relatively similar. And what we do here, which is super stupid, is we go over all the backtracking objects, basically all the nodes, check whether they are open because we don't want to jump to a closed node. So closed basically means if we pruned, if we've done with that node already, if it has children or if it's infeasible or solution. And if it's open in depth first search, we use if the depths. Yeah, this one is actually wrong. I thought I corrected it. So the one with the highest depths and if same choose better bounds. So yeah, depth first search basically means going like down the tree and don't want to jump up if you don't have to. If it's not infeasible, we just go down, down, down. And it can happen that they have the same depths, and then we want to choose the one with the better bounds, if that makes sense. It's not necessary, but I think it's not too stupid, depending a bit on how long it takes to jump in the tree. But anyway, yeah, this one has also the nice feature of being deterministic, whereas the priority queue, depending on the implementation, it might be non-deterministic. So in general, the idea is to remove this part and use a priority queue instead, and depending on the order in the priority queue, we sort the stuff. What we need for that is a package for the priority queue. I still want to have this, like basically the same functionality. So if they have the same depth, I want to do some like compare the bounds. For best first search, it's basically the opposite. So I copy pasted that comment probably from that. Then we check the bound first, and then we check the depth. And this one is like O of n looking over it. The other one, priority queue, will be probably based on the implementation, pending a little bit log of n, and we don't check the closed nodes anyway. So that will be much faster. I want to have the same functionality, so we have to check the priority queue a little bit. Julia. So why am I not? Okay. Anyway, how's everyone doing in the chats? So yeah, we want to have this data structures.jl. Oh, we want to update some packages. Didn't take too long. And we probably want to have some kind of test set. That sounds good. Being lazy sounds good. Using revise. I'm procrastinating programming. Maybe I should do something else. No, okay. No. Wait. Test. Yeah, test. Then not so much. Anyway, prior. Okay, using, what is it called? Data structures. I have that installed. Okay. Now, we probably want to have a look at the basic stuff first. Which means construct a new priority with keys of k and priorities of forward ordering. Okay, so probably we take the smallest, right? The lowest priority. Why is it the lowest? I find this very weird. That's okay. Okay, so I don't need these functions actually, because I can do it like this. And to have this delete. Okay, but let's check that out first. I don't know actually whether this will work out. I normally don't use this Julia REPL VS Code stuff. So, okay. I don't know, trying something new every day, I guess. Okay, so now we have that part. Now we have, so for me it would be somehow the ID of something, and then we have a priority, and so this is probably not the best thing. Key. So you probably want to have int and float 64 in this example. Now we have int float 64 and forward order. Yeah. I'm wondering whether it makes sense to always use forward ordering and then store them negatively in some cases, or make it based on the what is it called? The sense, like whether it's minimizing or maximizing the problem. But the depths will always be there. So maybe I want to backward order it. I don't know. Backward ordering doesn't work. Base order reverse. because now I want to have something like this. And bounds. Okay. Anyway, and then we have priority here. And we have priority of, I don't know, depth 10. Let's make it. And bound of 5.5. And priority Q is depth of 11. Okay. Now we need this function. Priority P2. Okay. And two priorities are like P2 is less than P1. Oh. Okay. Do I want to have priority for DFS and priority for BFS? Maybe. Oh yeah, but I can use, yeah. I think that's making it easier. Huh, I have to think about that for a bit. But so if P1 P2 dot depth is smaller than P1 dot depth, then return true. Else if P2 dot depth is the same as P1 dot depth, then return here and return P2 dots bounds smaller than P1. Okay, so PQ. We have both of them, then have peak, PQ. Why? Wait. Why is the okay. Strange. Okay. Okay, so PQ1, right, PQ1, PQ2. Oh, I did this wrong, right? So P1, P2. I don't know why I messed this up. So this is P1 smaller than P2 than I did the other. Perfect. And now we have this one, but so we want to maximize in general. So 7.5. Then we have 2.5. 7.5 is the best. Then we have DQ, PQ. Then we have 2, 4, 1. All right, that sounds good. Identical keys. Choose. Yeah. Okay. All right. Yeah. So one for depth first search and best first search. The question would be, do I want to have factor 1 and factor 2, like which one is more important, and have just one priority struct? Or do I want to have priority DFS, priority BFS? Oh, and switching from DFS to BFS would mean that I have to change all keys, which is quite annoying. And I don't use that method often. I think TBFS. Like one test case. Okay. What is the chat thinking? Any ideas? Um, so we do DFS first, and then we care about the rest and see where we fail. It's all right. Yeah, but I think I'd like to not confuse them. So let's make them clear. Types. Do we have some types? Okay. Abstract type priority. And then we have structs priority. And now we have depths. And we have some T real, which is from bounds. Okay. And we have this function. All right. Oh, activate. Oh, add data structures. Okay. So we have simple test case. Graph coloring. All right. Let's do this. Include graph color. See whether that still works. Okay. Oh, I think we should have done one thing. One more thing before. Okay. And that is constraints solver model. So we have our backtrack objects here, but now we want to have like a priority queue. So backtrack priority queue is priority. No. Data structures. Okay, maybe we did it before pre-compiling, so maybe it works. Okay, then we have I will get myself some water. All right, I'm back. Pre-compiling. Done. Let's see. It's an error. Oh, yeah. Backtrack. Wait. Okay. So this is priority queue, which takes in an integer and priority, and is base order reverse. Oh, all right. By the way, why did the Kaggle challenge not start yet? All right, that works. Okay. And it's oh, how do I make abstract? I don't know. Let's keep it that way. Okay, and it's fast. All right. But at least we have some backtracking, so that's important. Always work. Let's create a branch. Feature priority. All right. So now, when we add something to backtrack back, we need to set the priority, and then we have to change the priority at certain spaces, and delete it when closed. Okay. And depending on maximum. Okay, maybe that's not what it's called. Okay, do I have the function I want? Add to backtrack back. So basically, um, all right, add to Um, oh, and now, okay, if, okay, maybe we check first, DFS. In that case, we want to have con dots. I already forgot how I named it. Backtrack P. Probably a terrible name. Index equal to priority DFS of backtrack object dot apps and backtrack object dot negative. No problems with that. That sounds good. Let's just delete. Okay. Then we have closed. Okay. So we want to probably have close this. Because we want to do several things. Okay. And probably in traversing. Yeah, it probably makes sense to have that parameter. Okay, and we want to have backtrack back index dot status is closed, but we also want to have something. No, actually, don't. I just have to delete it. Backtrack. Oh well. Should only delete it if it exists. Backtrack PQ index. Not going good. Oh, that's true. Memory color closed nodes. And then we call this index. I think that seems to make sense. Okay, now just change this. All right. Sounds good. Now we have gets, bests, bounds. Hopefully. It's not too important. Should be. Put this in helps. Bounce. And we have backtrack PQ. So maybe updates backtrack PQ. It's also a reasonable function, which takes in the backtrack objects index and the best bounds. And I think it's also set like this. And let me also let me also put a docstring to it, probably. So we have this again. Traverse strategy DFS. and if com.sense. Maybe backtrack. And then we have com backtrack PQ of backtrack objects. Index is priority TFS of backtrack object depths and minus best and plus best. This like that, right? Okay, maybe. Oh. I don't want, like, sometimes I call this with a variable, and I don't think I want to change this. But I'm not too sure. Okay, that gets updated. I think it's okay. Okay, so let's not forget our doc strings. Updates here with the best. Okay, that's good enough. Okay, now we have DFS. All right. So what do we have in the end? We basically just have the and we don't want to delete it. Just want to peek. Okay, so oh, and okay, probably check whether it's I still have this. Yeah, is empty. actually was empty. Sorry about that. Sorry again. Wait, where's this? Okay. It's going. That is the correct shortcuts. Okay, I wanted to go to here. So basically is empty, backtrack, then return false, not found, and backtrack object. Otherwise, okay, backtrack. Backtrack peak protein. Still do the same thing. Just it got slow. A bit slower than this one. I don't know. Okay, no, it's very fast. All right. Maybe that's it. Let's run the test cases. Yes. Oh, maybe I can do def. Includes. Okay, I'm getting a little bit hungry to be honest. I have some other stuff to do as well. So I'm thinking whether I will stream in about 4 hours again, on maybe finishing this up and the element constraints. But let's run the tests first and see how far we can go. Well, hopefully we can solve all of them. Tester. Well, you need to test code, right? Especially my codes. So, time to check the new Kaggle sign in. How do I sign in? With Google? I don't know. Okay. I'm not signed in into Google. Let me check whether. No, I actually have a password for it. I know it didn't start yet, but you can always look, right? Okay. We are all waiting. Everybody is waiting. Who is waiting on all the stuff? Anyone on the chat who's also waiting for whatever? Oh, I wanted to check whether this actually works. It does work. I'm fascinated. Waiting for a miracle that gives you a lot of money. That sounds good. Okay, we have an error. Oh, probably because we just because the function test is stupid. Um, I think it's always a good idea to have a backup plan for your waiting miracle. Um, maybe work on the backup plan of how to even get money without a miracle. Be quiet. I'm sorry. Okay. Um, let's put it in here. We are stupid. Yeah, I think I want to have this as a function. Uh, hopefully this will run fast enough, and hopefully it doesn't fail. You never know. Still fails. Oh, because I didn't save it, and I should probably call it like this. Still fails. Oh, but I also. Okay. Oh yeah, maybe. Oh, maybe I should. No. Sometimes I don't get it. So, what is the problem right now? Oh, why is this? I have the feeling that this test is just bullshit. Okay. Okay. Um, Oh, this one is actually wrong. No. Okay. I think this is how it works. Okay. It is a bit weird, to be honest. Why didn't that fail before? But okay. Oh yeah, and I also this is actually correct. I really don't know why the other one worked, because this one gets a pair and a priority. Here, I mean there. Finally. Oh, because this one doesn't use DFS by default. Okay. What a stupid test. No. Where is optimize attributes? And now we have traverse strategy as DFS. Okay, this takes more, but it didn't fail. Okay. That's all okay. So what kind of miracle can give you a lot of money? Like, seriously? Are you playing the lottery? Or do you think you will just find a lot of money on the street? Oh no, we have an error. at index 0. Okay, that's unfortunate. Oh, so you start, but you have to do it, right? It's not a miracle. The miracle would be if you would get rich out of it. I had the same thing. Miracles aren't very reliable. Yeah, that's that sounds about right. Why is the last backtrack index 0 at that point? Is the problem formulation first of all? No, it's not even a DFS problem. So why is that error there and it wasn't there before? That is the big question. Do we have a time limit? Let's have um, okay. Separate. Include test.jl. Oh, sorry. Double tickets. What is double tickets? What? LPK. Oh. Uh, let's just call it again. So the only thing, then we would have the error. So normally the last backtrack index should be set at least once. That's why I have this thing. What do you mean by CS not defined? I define it here. Oh, that one needs worries. And I thought I got rid of this one. But maybe in a different branch. Okay. I really need to do this activity-based branching, but it doesn't work that well yet. There are some other good ideas in that branch that I might need to bring out of that branch. Okay, so we have it defined here. We should definitely go into that. What happens if oh, right. We have some test output. Uh, yeah, I don't like errors that are not reproducible. So most of the cases it works. And time limits are always things that are not easily reproducible. Okay. Okay. At least I get the error again. Otherwise, really not equal. And for DFS, I get a different error. It's okay. Oh, it's actually not this. This one. Oh, okay. We are actually in this case, which fails in DBFS. Okay. And then let's run this. Oh, DBFS. Huh. I know why it fails, which makes sense. Yeah, DBFS doesn't work because it calls DFS first and then BFS. But for DFS, the priority queue doesn't exist, and then everything breaks down. Okay, that makes sense. But I really need to get some food. So let's go to this screen. And thanks everybody for watching. I will stream in about 3 hours, maybe. I can finish the crap up that I produced. And yeah, special thanks to all the Patreon subscribers who support this Twitch stream, or basically all the work I do on my blog, OpenSource.js, and the Twitch streams, some YouTube videos, and stuff like that. And the 4 people you see here from time to time are the ones that spend more than $4. And if you want to support me, you can support me with as little as $1 per month. And you get all the blog posts as early as basically you can get them, as early as I finish them. And the rest of the world has to wait 2 more days to receive them. All right. See you later, probably.